Welcome back, dear friends. We were discussing about power plant economics, and in my first video, I tried to explain you the concept of fixed cost. So this is in continuation. We are basically looking for some knowledge, some concepts which will help us to compute finally what is the cost of generating 1 unit of electricity. So any power plant which we have, I should be in a position to calculate its cost of generating 1 unit of electricity. So we'll continue with these concepts. A quick recap of what we had done in the last lecture, and then we'll continue with the concept of running cost. So this was the outcome which we framed. We were talking about the two components in the cost per unit. One is the capital cost and other is the running cost. And I said that typically the capital investment is 4 to 6 crores for every megawatt. The capital cost has a bearing on the fixed cost. Fixed cost has to be calculated for every unit of electricity generation, whereas capital cost is the total cost. Fixed cost is to be expressed in rupees per kilowatt hour, and we said that the fixed cost is a function of two parameters. One is the cost of capital and second is the operating hours. Cost of capital, I said, is a function of the rate of interest at which the capital is borrowed and also the depreciation. And the other important parameter which would influence the fixed cost is the operating hours. It is always desirable to have more operating hours. And what decides the operating hours? So operating hours, you can think over it. You can just pause this video and think and list them. What would decide the operating hours? Operating hours are decided by many parameters. The how old a plant is. Okay, what is the technology of the power plant? That would influence the operating hours. If the plant is too old, and then it would be into more maintenance. If the maintenance is more, the operating hours would be less. So it is not desirable, obviously, that there are more maintenance hours. Second thing is, if the technology is fossil fuel technology, then the operating hours would be more. If it is a renewable energy technology, generally speaking, the operating hours would be less. Why? Think over it. If we compare a coal-based power plant with the solar power plant, whose operating hours will be more? The operating hours of the coal-based power plant would be more. The reason is we can operate the coal-based power plants 24/7. However, we cannot operate a solar power plant 24/7. Why is that so? Because the sunlight is constrained. We don't get sunlight 24/7. The other parameter which would influence the operating hours is the load on the power plant. If it is an industry which is nearby, the load would be more, the operating hours would be more. If it is agricultural load, then it would be erratic load and the operating hours would be less. So operating hours is not simply the function of the power plant, it is also the function of the load on the power plant. As I was trying to explain also in the last lecture, that a fixed cost has to be kept as minimum as possible, and if we want to minimize the fixed cost, then we need to increase the operating hours. The reason is, if you have more operating hours, the fixed cost would be divided amongst that number of hours. To help you understand this better, I take an example of a taxi, not of a personal car. Taxi is an investment. If you want to purchase a taxi for, let us say, Ola operators, they have a taxi. If I run for more number of hours, then the interest per kilometer which I will be paying would be less. If I buy a taxi and park it at my home, then the entire interest, okay, which I will be paying to the bank, that won't be put into any use. So 10 kilometers per day and 100 kilometers per day, anyway I will be having to pay the same interest to the bank. So it's better that I operate the taxi for more number of hours. Similarly, when I'm making an investment on the power plant, if I want to reduce the fixed cost, I need to operate the power plant for more number of hours. The second parameter of interest is running cost. Running cost or operating cost. It is also known as variable cost, and it is a function of the fuel cost, the labor cost, and the maintenance cost. So if I don't operate a power plant, then obviously the power plant will not consume any fuel. If I don't operate the power plant for a year, then I need not employ any labor for operating it. So the cost of operating a power plant is a function of the fuel cost, the labor cost, and the maintenance cost. So even if the plant is a 100 megawatt power plant, its running cost would be zero if I keep it idle. Okay, but that is not desirable. Why it is not desirable? Because in any case we will be paying the fixed cost. Taxes, like power plants, if they are not operating, then they would incur zero petrol bill, zero diesel bill, right? Similarly, power plants, coal-based power plants, if they are not operating, they will have a zero bill for coal. So, on what parameters would running cost depend on, and how to reduce the running cost? Because ultimately, if I reduce the running cost, then the cost per unit of electricity generated would be lower. So, the running cost would depend upon the efficiency of the plant. If I operate the power plant at higher efficiency, the fuel consumption would be reduced. If the fuel consumption per kilowatt hour of electricity generated is reduced, it's called a specific fuel consumption. If it is lower, the cost, the running cost would be lower. So it is desirable to operate the power plant at higher efficiencies so that the running cost is minimized. The second is what is the cost of the fuel in the market. If the fuel is costly, you know that coal is costlier than biomass at some places, then the cost of running that plant would be higher, right? So depending upon what is the fuel price, the running cost would be variable. Now, fuel price is not the parameter which is totally in the control of the plant engineers. It is dependent on many parameters. It would depend on the exchange rate. It would depend upon whether the world is at peace or at war, right? If there is a war-like situation, you know that suddenly the petroleum prices, the fossil fuel prices, they increase. So the cost of the fuel is very volatile, and that makes the running cost also very volatile, very variable, right? An interesting point which we can discuss later is renewable energy technologies, like say solar thermal or photovoltaics. They have no fuel cost, right? Because they are operating on the free energy, which is that is a renewable energy. Now, whether and think over it, whether the running cost of the renewable energy plants is zero. Okay, you can answer this, you can think over it and answer it later. As discussed, we are basically talking about the economics of power plant, and we are interested in computing the cost per kilowatt hour of generating electricity of any power plant. And as we said, how to arrive at the cost per kWh? Look at the expression. What is in the numerator? Numerator, it is a cost. Which cost? It is an addition of the fixed cost and the running cost. How to calculate the fixed cost? Fixed cost is calculated as the addition of the rate of interest plus the depreciation rate into the capital cost. So assume that the rate of interest is 5%. Assume that the depreciation is 5%, 5 plus 5, 10. 10% of the capital cost would give me the total fixed cost. How is the running cost calculated? Running cost, if you want to calculate the annual running cost, add up the salaries of all the employees, add up the fuel consumption cost of the entire year, add to it the maintenance cost, total it, that would be the running cost. So the total running cost plus total fixed cost would be the total annual cost. You can get this value in rupees. That would be in the numerator. In the denominator, depending upon the operating hours, we will get the kilowatt hours, that is the units the power plant is generating that year. That comes in the denominator. So the cost in the numerator upon the total units generated by that plant in the denominator will give us what? It will give us the cost per kWh which we are trying to compute. And this is a very important parameter we need to understand. If you want to get your concepts clear, okay, I would recommend this exercise for you. And this is an open-ended exercise. It is not simply, I'm not giving you any data for that. You need to do some homework for that. So this exercise is, you estimate what is the cost per kilowatt hour of a 210 megawatt coal-based power plant. Now, how to solve this? You have to assume many things. You have to assume. And how will you assume? You have to assume by actually visiting the chief engineer of a thermal power plant, or looking at some research papers which will give you the capital cost, getting an understanding of what is the fuel used in that plant, what is the efficiency of the plant. For getting the plant efficiency, you need to meet the engineer, you need to look at the data, you need to ask them what is the typical plant efficiency, and then based on for given year what was the operating hours and what is the number of units that plant is generating. That data you need to calculate. Because if you don't do it, if you just get some values from the book and do the calculations, it would be simply a mathematical exercise. If you want to really understand the economics, because it's a very involved subject, you need to actually get the data from the field. The way I had explained you can calculate what is the cost per kWh of a coal-based power plant. Now, what is the other part of the problem? The other part of the problem is you need to compare this cost with all other power plants which you know. Again, this is a major project. You compare it with the hydroelectric power plant. So go and look for a hydroelectric power plant around you. Do the same exercise, collect the data. Do it for wind, do it for nuclear, do it for diesel power plant. Find out what is a gas turbine power plant, where it is located, the solar PV plant of a similar capacity. Okay, all this data, if you do some field research, do it on internet, whatever way you like, get that data and then convince yourselves that you are in a position to compute the cost per kilowatt hour of a power plant. If you do it, and if you do it, I bet, I bet that you have understood the economics of power generation. Thank you very much.